Hi there, my name is Janvi, and today Ekta and I are going to demonstrate our project for the course Semantic Web Engineering for fall 2025. So, our project's name is FoodPriceNet, which is an ontological approach to the semantic modeling of food price relationships. So, through this project, we are just trying to create a knowledge graph based off of food prices, and we are going to try to query them using SparkQL. So the agenda for this project is we'll first begin with the introduction of the project, the objectives of the project, what it is meant to do, and why did we choose to take up this project topic, followed by the application demonstration, wherein we'll show you a brief demo of how the application is set up, how it works. And at last, we'll also demonstrate how the application can be used by running a few sample SparkQL queries to show outputs. Can I have the next slide, please? So here are the project contributors. We have all the names of the group members of group 5 who have worked on this project. Each has contributed in separate ways, ranging from developing the application to designing the ontology to even contributing towards creating the report. So let's start with the introduction of the project. So what exactly was the intention of making FoodPriceNet? Can I have the next slide? So FoodPriceNet is a semantic knowledge graph which was initially created to represent and examine the connections among food categories, the consumer price index, and the producer price index. Now, for context, the consumer price index is basically an index which determines how much the consumer has to pay, the amount that a consumer has to pay for a certain food product that is sold in the markets. Whereas the producer price index is a value that stands for the amount of money, the amount or the cost that a producer obtains or gets by producing a certain food product that is available to markets. Now, through the integration of various economic indicators, we have created an ontology, and this ontology with this project will actually provide a perspective on how the price fluctuations in certain food categories will correlate throughout the food supply chain, right from the producers who produce the food items to the consumers who actually purchase these food items for consumption. So FoodPriceNet, like any other knowledge graph, employs semantic web technologies like RDF, OWL, and SparkQL, and this will depict the food economy concepts in a very easy to understand, machine readable, and expandable format. We aim to analyze the pricing connections. We also want to connect the data sets with common vocabularies and execute queries, which will help us understand the correlation between the CPI, the PPI, their relation to each other, and how these affect the economy of food in general. Okay. Here are a few screenshots of what the application looks like. So we have the Fuseki server locally. And then we have the front page of our application that we created. So this is actually what the
Yes,
front
we
page looks
can
like.
explain in the application.
So here are a few sample queries that we tried running on our system. We can see that the query board contains the query that we've run for the application. Then we have the query results, which will print the results either in a tabular format, a JSON format, or a CSV format, which can be copied or downloaded according to the user's convenience. And then we have a query visualization panel, which will graphically visualize the query results, the results that we've obtained from the SparkQL query that we ran. So this particular query actually is going to retrieve the average CPI price per item in the FoodPriceNet knowledge graph that we've created. So this is a brief overview of the high-level system design and the basic workflow of how our application works. It starts by the input data, which is in the form of Excel files. So initially we had like 2 Excel files that we took from the US Department of Agriculture website to understand the food categories that are available to consumers and producers, and also the prices and the price ranges that are associated with each category. We take these Excel files, we prepare the data by cleaning, formatting, and processing the data, taking in the columns that we need and disregarding those that we don't. Eventually, we ended up building a more cohesive uh, set of data for the CPI and PPI separately to actually highlight the relationship between a certain food product, the PPI and the CPI that is associated with each food product separately, and the rate of change of the prices of the PPI and the CPI for both. So we have the data preparation. Once the data preparation is done, we actually take the data and convert this data into RDF triples, especially in a turtle format. Now, through this project, we have actually achieved this by defining a particular Python script. So we have a Python script which will actually convert the data we have in these Excel files into RDF triples. The RDF triple files are generated will be in the format of a turtle file. Meanwhile, at the same time, we'll also have our ontology, which we have defined to ensure that we have the classes and properties that adhere to properly structuring the data in our knowledge graph. So, along with the RDF conversion and the ontology modeling on the side, we have the triples ready. So, the triple store that we've used for the application is Apache Genafuseki, which is basically a lightweight triple store database. It stores RDF, OWL, and also enables the querying of the knowledge graph via SparkQL queries. And meanwhile, for running the application on the front end, we have the OWL reasoning, which is the ontology based inference based on how we have defined the classes, the property object properties, and the data properties in the OWL file. And at the same time, we have SparkQL queries, which are run on the user interface, which will basically show us the results and the visualization as we showed earlier in the front end sample queries. Now, to explain more about the FoodPriceNet ontology design, this is the basic ontology design we have. Our ontology is basically an extension layer of two existing ontologies that exist. That is the food on ontology, which is a food-based ontology. And then we have the solicit, which explains mostly about like certain common data formats that are available, such as price or date ranges and stuff. So we combine these two ontologies and build on an extension layer called FoodPriceNet, which we will actually use. And moreover, there's a SparkQL interface through the front end, which will be able to query the application and get the desired results. So this is just a basic view of our ontology. We used WebVowl to visualize the ontology, how the classes, the object properties, and the data properties correlate with each other in the ontology. So this is just this. Please do keep in mind that this ontology over here, it is just a representation of the extension that we've created and not the whole ontology itself.
And for clearer picture, we have added in the paper also.
Okay.
That's it.
Can we get the next slide, please? Yeah, so these are a few images of the classes and the object properties that we added in our ontology. So on the left, you can see the classes. On the right, you can see the object properties. And on the next slide, you can see that we have defined the data properties accordingly for our ontology. All right. So these are the participants of our projects. This is basically the individual contribution of what everyone has done in the project. Now we can just move over to the actual demonstration of the application. So the application over here, this is the basic project structure wherein we have the backend, the front end, the data sets, and all of these have basically been bundled up into a single Docker container. So when we actually run the command docker compose up build, what it will do is, assuming that you have a fresh repository that you've cloned, it's going to build all these containers and you'll have the application ready made. Once the application is done, you can basically access it at localhost 3000, which is the port on which the front end has been deployed. So since we already have this up, I guess we already have the application running on the system. Yeah. So this basically means that the containers, the images have already been loaded, the container is ready. So we can actually access the application at localhost 3000. So once the application loads, we can head over to the query board. Okay. Now for demonstration purposes, we'll take the first and the second queries of the simple queries. The first query will basically list all the food items or all the food categories that are there in the knowledge graph. So on executing it, you can see the results and the graphical visualization of the results as well. We have the item, which is in the form of the URI, the Uniform Resource Locator, and then you have the labels, which shows the categories in human readable format. Mm, so we can also choose the way we want to visualize the query, and we can also see it in full screen for better viewing ability. These are the different ways in which we can visualize it. The application also has options to save and download and copy whatever results you get. So for the next thing, we'll try implementing the CPI observations for a single food category in the knowledge graph. This is how we get the results. We have the results in the form of URI, the date, the price, and the change rate. The change rate contains rates from the lower bound to the upper bound. And then we have the visualization of the query as is in the visualization panel. Now, the third query that we'll take is like a complex query. We'll take one complex query, which is the month of maximum PPI price per item. So once we try to implement this in the UI, so this is where we get the results. We have the item label, the food category, we have the maximum price of that particular food category for the month. Now, there's obviously going to be 1 month wherein the price, the PPI price, is going to be the highest for that particular category of food. And that is what we have planned to retrieve in this query. So essentially, through these three queries, we can see that this project aims to perform like an exploratory data analysis of how the prices change for certain food products over a period of few years. In this dataset, we have actually considered the period of 5 years. So we're trying to understand how the PPI and the CPI prices change for certain food products over a span of 5 years. So in a sense, it gives us insights into inflation. It can also track the current status of how expensive certain food items are and how likely the prices are going to rise or fall. So that is the ultimate aim of the project. And thank you for listening to the demonstration.